Good morning everyone. How are you all? I hope all are doing good. So as of now we have discussed about Bohr's atomic model. Okay. So here Bohr's taken the only hydrogen atom and he has explained about the hydrogen atom, total energy, Bohr's radius, Bohr's velocity and energy, everything explained by Bohr, and he has taken only the hydrogen atom. Okay. So here why Bohr's atomic model fails. Okay. So here today I am going to discuss about the drawbacks of Bohr's atomic model, and it leads to the Sommerfield's theory. Okay. So Sommerfield's next atomic model is Sommerfield's atomic model. So here Bohr's fails to explain such properties. Here I would like to explain. See, so here the Bohr's atomic model can't explain the spectra of atoms more complex than the single electron elements. Okay, so here already I told you hydrogen atom contains a single electron. So Bohr's explain only single electron system. So Bohr's does not explain the more complex spectra. So here spectra means what? For example, already I told you the electron which is in the excited state, when it comes to the ground state, it emits the radiation, right? ఎప్పుడైతే ఒక ఎలక్ట్రాన్ ఎగ్జైటెడ్ స్టేట్లో ఉంటుందో, ఎగ్జైటెడ్ స్టేట్లో ఉన్న ఎలక్ట్రాన్ అగైన్ when it comes to the ground state, it is while coming to the ground state, it releases the radiation. If you see that radiation to the high resolution microscope, high resolving, ఆ రేడియేషన్ని కనుక మనము ఒక హై రిజాల్వింగ్ టెలిస్కోప్లో కనుక చూసినట్లయితే దెన్ యూ విల్ అబ్జర్వ్ ద స్పెక్ట్రా ఆఫ్ దట్ పర్టికులర్ ఆటమ్. సో ఇక్కడ ద హైడ్రోజన్ ఆటమ్ ఈజ్ ఓన్లీ కన్సిస్టింగ్ ఆఫ్ వన్ ఎలక్ట్రాన్. సో దిస్ సింగిల్ ఎలక్ట్రాన్ ఆటమ్ ఓన్లీ కెన్ బి ఎక్స్ప్లెయిన్డ్ బై ద Bohr's atomic model. Okay, and it doesn't explain the complex spectra of different, for example hydrogen, next helium, next lithium, next boron, next beryllium. So what happened to the different spectral lines of next coming atoms? This won't be explained by the Bohr. So that is why Bohr fails to explain the spectra of atoms which are more complex than the single electron, like helium, lithium, beryllium, boron, carbon, like that. So here and next he also does not explain the following properties. What are the properties? Those are the distribution and arrangement of electrons, how the electrons are distributed and how they are arranged. Okay, this is also not be explained by the Bohr. The distribution and arrangement of electrons are also not explained by the Bohr. Next, intensity rules, and next selection rules, and next fine structure. What is the fine structure exactly? So that is we will explain in the next slide. So chemical bonding. So see here, chemical bonding means if you take the water molecule means what? H2O. So H2O means if you split it, H plus and OH minus, it is a water molecule is a combination of H plus and OH minus ions. So how the chemical bonding in between H plus and OH minus ions? So that is what not explained by the Bohr. Okay, and next Stark effect and Zeeman effect. Splitting of spectral line in the presence of electric field is called Stark effect. Splitting of spectral line in the presence of magnetic field is called Zeeman effect. So Stark effect and Zeeman effect are also not successfully explained by the Bohr. So that is why the Bohr's theory fails to explain these are the following rules. So that is why this atomic model is failed. So see here in the next slide, if you observe, okay ma, so here if you take this spectra and see in a high resolving telescope, you will observe this is each line in this spectra again split into many number of lines. Why this is happening, why that line is splitting into many number of lines, that is not successfully explained by the Bohr. That is what about selection rules, fine structure, and next intensity rules, and Stark effect, Zeeman effect. So all these techniques are not explained by the Bohr successfully. That is why Bohr's atomic model failed, and next atomic model came into the picture by Sommerfield. He is a scientist and he has given the modification of Bohr's atomic model. So that theory is called as Sommerfield modification of Bohr's theory. So we are going to discuss about the Sommerfield's modification of Bohr's theory in the next slide. See, Okay, see here, this is Sommerfield's elliptical orbit. So in this case, according to Sommerfield, electron revolves in an elliptical orbit. According to Bohr, electron revolves in a circular orbit. So Bohr ఏం చెప్తాడు, ఎలక్ట్రాన్ అనేది న్యూక్లియస్ చుట్టూ ఒక సర్క్యులర్ ఆర్బిట్లో మాత్రమే రివాల్వ్ అవుతుంది అని చెప్తాడు. బట్ సోమర్ఫీల్డ్ ఏం చెప్తాడు, దట్ థియరీ కంప్లీట్లీ ఫెయిల్స్ అండ్ సోమర్ఫీల్డ్ కేమ్ ఇన్ టు ద పిక్చర్ అండ్ సోమర్ఫీల్డ్స్ గివెన్ ద థియరీ. ఇన్ దట్ కేస్ ద ఎలక్ట్రాన్ రివాల్వ్స్ ఇన్ ఎలిప్టికల్ ఆర్బిట్. ఎలక్ట్రాన్ అనేది న్యూక్లియస్ చుట్టూ ఎలా తిరుగుతుందంట, ఎలిప్టికల్ ఆర్బిట్లో మాత్రమే తిరుగుతుంది. అండ్ హీ హ్యాస్ గివెన్ సమ్ అజంప్షన్స్. సో ఇన్ దిస్ కేస్ ద ఎలక్ట్రాన్ పొసెసెస్ 2 వెలాసిటీస్. అంటే సర్క్యులర్ ఆర్బిట్లో తిరిగినప్పుడు ఎలక్ట్రాన్కి ఓన్లీ 1 వెలాసిటీ మాత్రమే ఉంటుంది. బట్ హియర్ ద ఎలక్ట్రాన్ పొసెసెస్ 2 velocities. One is radial velocity and another one is transverse velocity. See here, for example, in case of revolving of electron, see here, when the electron is revolving around the nucleus, for example here it is a nucleus. Okay, so here it is a nucleus, for example here it is a nucleus. Okay, and next this is an electron. The electron is revolving around the nucleus. So whenever electron is revolving around the nucleus, there are 2 velocities acting on the electron. One is along the radial line. Along the radial line, 1 velocity, that is radial velocity. Along the tangent line, another velocity called transverse velocity. Along the tangent line, the velocity is transverse velocity. Along the radial line, the velocity is radial velocity. Okay, so here the elliptical path consists of semi major axis and semi minor axis. Okay, so here see here, electron possesses 2 moments. So in case of Bohr's atomic model, he has given only principal orbital number, that is only n. But already I told you that the electron revolves in an elliptical orbit and it gives the 2 velocities. One is radial velocity, another one is transverse velocity. So that is why the electron possesses 2 velocities. So in this case, the value of n, okay, the value of n is splits into nr plus n pi. The value of velocity, the value of the principal orbital number can be split into nr plus n pi. Okay, see here. So the principal orbital number in case of Bohr's atomic model can be split into radial number and transverse number. Here nr means what, Nana? Radial quantum number. Okay, nr means what? Radial quantum number. And n pi means what? Azimuthal quantum number. He has named the n pi value, that is azimuthal quantum number. What is it? Azimuthal quantum number. And here azimuthal quantum number n pi starts with 1. Okay, next 2, 3, 4, 5 up to so on, all the integer values. And next here nr is a radial quantum number. The radial quantum number starts with 0, 1, 2, 3 up to so on. The nr value starts with 0 only. So this is what about the Sommerfield elliptical orbit. If you look at the different phases, and he has explained, Sommerfield explained the more than the complex structures of different atoms. Bohr's taken only hydrogen atom and he has explained the spectral series. Okay, everything was correct about the hydrogen, but what happened to the complex structures? He has fails to explain the complex structure spectral series, that is helium, lithium, beryllium, boron, like that. Okay, but Sommerfield successfully explains the complex structures spectral series. So here see, if n is equals to 1, what happened? In case of n is equals to 1, there is only existence of n pi is equals to 1. So n and n pi both are equal, then we will get the circular orbit. Okay, in case of this, you see. And if n is equals to 2, n is equals to 2, in case of what happened? N is equals to 2 means, for n is equals to 2, we are having 2 values. N pi is equals to 1 value and n pi is equals to 2 values. Okay, so here whenever n and n pi are not equal, whenever n and n pi are not equal, we will get the elliptical path. Okay, whenever n and n pi not equal, we will get the elliptical path, but whenever n and n pi are equal, we will get the circular path. Here electron moves around the elliptical orbit and circular orbit, both are here, both the cases are possibility. There is a possibility of both the cases in case of Sommerfield's theory. Okay, for example, if n is equals to 3, n is equals to 3 means n pi is equals to 1, n pi is equals to 2, n pi is equals to 3. Okay, in the three cases, whenever n and n pi both are equal, that case is called circular path. But n and n pi not equal, in that case there are two elliptical orbits like this. Okay, so in detail I will explain in the next video the total derivation and different elliptical paths, what happened to the energy levels, what happened to the spectral series of different atoms. In detail I will explain in the next video. Thank you.